Hey everyone, I am Abhilasha, the tech girl, and welcome to my special math series for my younger brothers and sisters who are preparing for their board exams. I know math can be overwhelming, so I'm here to help you prepare it easily and without any stress. With just a couple of hours a day, you'll be fully exam prepared. Today, we are starting the first chapter of Algebra, which is polynomials. This chapter carries around 5% of weightage in your board exams. It is the foundational topic of algebra. So let's break it down into small steps and examples so that you can score full marks effortlessly. Stay till the end for practice questions. Today's chapter is polynomials. So let's start with the basics. What is polynomials? Polynomial is an expression made up of variables and coefficients combined using addition, subtraction, and multiplication, where the exponents of the variables are whole numbers. So, firstly, it's an expression, it's a statement, right? Polynomial is a statement which are made of variables, coefficients, and they are combined using addition, subtraction, and multiplications. The exponents of these variables are always going to be whole numbers. If they are not whole numbers, if they are integers or irrational numbers, they are not polynomials. So, firstly, what is variable and coefficient? Variables are the numbers which are not fixed in an equation. Okay, so let's take an example of polynomial. So 3x plus 2 is a polynomial. Yes. Here, 3 is a coefficient. It is a coefficient of what? Coefficient of x. X is a variable. So any numerical value in front, like any numerical value multiplied with the variable is the coefficient of that variable. And the number which does not have any variable, it is a constant. Okay. Now, in this case, the exponent of whole number, in this case, the exponent of the variable is a whole number. In this case, the exponent is 1. Yes, 1 is a whole number. So, this is a polynomial. Let's say if I said my equation was 3x plus 2. Is this a polynomial? Yes, it is. Why? Because the coefficient have a negative sign in front of it, not the variable. If variable had -1 as the power, it is not a polynomial. But since variable has 1 as a power, this is a polynomial. Some other examples for polynomial are x squared plus 4x minus 7. This is a polynomial. This is a polynomial where the power of x is 2. And here power of x is 1. So this is again a polynomial. Another example is this. Now this has a positive number as their power. So again, this is, okay, no power means the power is 1. If there was anything else, then there would be written x raised to power 0, x raised to power -1. X raised to power 0 is nothing but 1. So the variable attached to constant is nothing but x raised to power 0, and it's variable and it is equal to 1. That's why we don't have to write it. Okay. Okay. So this was about polynomial. Now, what are non-polynomial? Are there something called non-polynomials as well? Yes, there is. Non-polynomials expressions are like 1 over x or root x or x is to power -1. 1 over x is nothing but x is to power -1. Yes. So these values are non-polynomial. So if this is present in an equation, so let's say 3 root x plus 2. Is this a polynomial? No, this is not a polynomial. If I say x is to the power -2 plus 4 is to the power 4x minus 7. Is this a polynomial? No, this is not. Okay. Another thing is, now, if you see all three of these equations are polynomial, yes? But what is the difference here? The power here is 1, the power here is 2, the power here is 3. Based on that, the number of terms keeps increasing. What are terms? Terms in a polynomial, the sections which are added or subtracted with each other, the parts which are added and subtracted to each other are called terms. So this has 1 or 2 terms. This equation has 3 terms. And this equation has 4 terms, right? And that's why this is called binomial, because this is 2 terms. So bi means 2, nomial means equation. This is called trinomial. And this is quadrinomial. Or you can just call it polynomial. If it was just 3x squared, this is monomial. Okay? These are the different names. Now that is based on number of terms. Now, based on the power, the the highest power, there is another name of the equation, which is called linear equation. This is called quadratic equation or linear polynomial, quadratic polynomial. Okay, polynomial, quadratic polynomial. And this is called cubic polynomial. Why? Because the highest power here is cube. This is highest power is a power is 2. So quadratic polynomial, cube is cubic polynomial, and single power is linear polynomial. So we have 3 types of polynomial in a way. Linear, quadratic, and cubic. Okay. So linear is nothing but with highest power as 1. Quadratic is highest power as 2. And cubic has highest power as 3. So these are the different types of polynomials. Does that make sense? Good. And what are not polynomials again? Let's just quickly some examples. So tell me, I'm giving you some examples. Tell me which is polynomial and which is not polynomial. Is this polynomial? Yes. Is this polynomial? No. Why? Because the power is -2. Is this polynomial? No. Why? Because there is a irrational number present in the irrational variable present in the equation. So this is not a polynomial. Is that clear? Does that make sense? Okay. So the next part is what we just did. We just did the types of polynomial based on number of zeros or based on degrees, right? This was based, firstly, what is degrees? Degrees is nothing but the highest exponent of the variable. So if the equation is written in this way, let's say -2 minus 14x cubed minus 2. What is the degree of this equation? Is this 1 or is this 3? Of course it is 3. It does not matter that it was written first, okay? Because this is plus minus. You can write it as minus 14x cubed plus 3x squared plus 4x minus 2. Or you can write it in any other way. The easiest way to write is always in the descending order of number of degrees of variables. Okay, that's how it's universally accepted. But in the exam, just to confuse you, they might even jumble this so that you have to focus on what you're looking for. Okay, so since the highest power of this equation is 3, that means this is the degree of equation, degree of this polynomial. Degree of this polynomial is nothing but 3. Now, based on this degree, the polynomials have been classified into different types of polynomials. We just saw the example, which was linear, quadratic, and cubic. These are the type of polynomial. The general form of writing these equations are nothing but ax plus b, ax squared plus bx plus c, and ax cubed plus bx squared plus cx plus d. That's the general form of writing this equation, right? Now, number of zeros, maximum number of zeros. What is 0 now? We are going to see very quickly. Maximum number of 0 is 1, 2, and 3. So what do you mean by zeros? Zeros means the solution, okay? Basically, what will be the value of x for this particular equation? How many x value are going to get? So in linear equation, you're going to get 1 x value. In quadratic, you'll get 2. And in cubic, you will get 3 values for x. Okay. Zeros are nothing but solutions of these equations. So it is also called 0 because these are the value of x, which makes the polynomial as 0. So let's say 3x plus 4, right? So how do we find the 0 of this equation? We equate it with 0. Okay, now we find the value of x. So the value of x is nothing but negative 4 by 3. So if you put this value of x in this equation, your answer is going to be 0. And that's why this is called the 0 of the polynomial. Since this was a linear polynomial, we got 1, 0. When this is quadratic polynomial, we get 2. In cubic, we get 3. Okay. What does 0 mean in geometrical sense? What does the 0 of a polynomial mean in a geometrical sense is it's the x coordinate where the graph intersects the x-axis. So what else we can say? We can call them x-intercepts, right? X-intercepts are the value of x where the graph intersects at x-axis. That's called x-intercept of the graph. So, for example, we have an equation y is equal to 4x plus 3. Yes, this is a straight line equation, correct? And this is also a linear polynomial. Linear polynomial has how many x values? How many zeros? Number of zeros? 1. Very good. So number of zeros are 1. So let's say this is your xy coordinate. Okay. So since the y-intercept is 3, 3 is going to be here. And then it's going to be a straight line like this. Okay. That's it. This is 3, 1, 0. Okay. Just an example. Don't mind the inaccuracy. Okay. So for x is equal to 0, y is equal to 3. For x is equal to 1, y is 7. Right here, let's go. For x is equal to negative 1, y is going to be negative 4 plus 3, negative 1. For x is equal to negative 2, For y is equal to, for y is equal to 0, x will be negative 3 over 4. So this is going to be negative 3 over 4. So this, and this is what we calculated, right? 4x plus 3 is equal to 0, x is equal to negative 3 over 4. See, this is on the negative side, and this is what we are getting as 0. So this is where it's touching the x-axis. So that's what the 0 of a polynomial means. Now, the quadratic polynomial intersects x-axis sometimes twice, sometimes one, or sometimes never. It depends on the x-axis. It depends on the equation. So the maximum number of zeros is going to be 2, but it could be 1 or 0 as well. That depends on different equations. So quadratic equation. Similarly, for cubic, it will be 3, 2, 1. There is a relationship between 0 and coefficient. Okay. So let's explore that for quadratic and cubic. It's very easy to find zeros for linear equation, but it can be tricky to find it for quadratic and cubic, because you may have to do like long divisions or like hidden file methods, quadratic formula and everything. All those are options, yes, but there is always relationship between the zeros and coefficients, so that makes your job easier. What are the relationships? So for a quadratic polynomial, what is a quadratic polynomial? Ax square plus bx plus c. That's a quadratic polynomial. I'm writing this again and again so that it fits in your mind that quadratic polynomial has the maximum power of 2. Now, now there are two zeros here, right? So we are going to assume 0, 1 as alpha and 0, 2 as beta. So sums of zeros is equal to alpha plus beta is always equal to negative b over a. And product of zeros is nothing. Alpha times beta is nothing but c over a. C is this constant, a is the coefficient of x square, and b is the coefficient of x. That's where a and b and c came from. Okay. So for example, we have an equation x square minus 7x plus 10. Yes. So if we do the factorization, let's do factorization. 10 times 1 is 10. Okay, we need, so negative 5x, negative 2x is plus 10, right? Negative 2 times negative 5 is 10. So this is equal. Okay, now you take x common, x minus 5 is left here, negative x common, no, negative 2 common. Negative 2 common, so x minus 5 is left here. So you have x minus 5 common, and then x minus 2 is left. So your two zeros are nothing but 2 and 5 in this case, correct? X is equal to 2 or 5. Yes? Now, let's do this. Let's try this sum of zeros, which is nothing. 2 plus 5 is equal to 7. And what was the formula for sum of zeros? Negative b over a. What is negative b? Negative b here is, okay, b here is negative 7. So negative b is nothing but negative of negative 7, right? So negative of negative 7, and a is 1. So this comes up as 7, which is equal. So hence verified. Product of zeros is 2 times 5 is equal to 10, which is nothing but c over a. C here is 10 and a is 1, so which is again same. So hence verified. Make sense? So for quadratic equation, we have relationship between coefficient and zeros. The sum of zeros is equal to negative b over a, and product of zeros is c over a. Now, similarly for cubic polynomials. What is a cubic polynomial again? Ax cubed plus bx squared plus x plus d, right? So what we're going to do here, again, we have a relationship. So we know the number of zeros here is going to be, maximum number of zeros is 3. So now again, sum of zeros is equal to alpha plus beta plus gamma is equal to nothing but negative b over a. Product of zeros is equal to alpha times beta times gamma is equal to d over a. Since there is one more variable, one more coefficient, which is nothing but c, there is another one more relationship of products, okay, which is nothing but alpha times beta plus beta times gamma, products and sum of products. Okay, so alpha times beta plus beta times gamma plus gamma times alpha is nothing but c over a. These are the three relationships you have in cubic polynomial. Okay, let's see an example for this as well. Example for this is, let's say, x cubed minus 6x squared plus 7x minus 6. Okay, this is your equation. And if you calculate it, you will get x. So if you see 1 minus 6 is negative 5, negative 5, negative 6 is negative 11 plus 11 is 0. So x minus 1, the equation is x minus 1 times x squared minus 5x plus 6. Now you do it for this. So x minus 1 times x squared minus 3x minus 2x plus 6. X minus 1, x is common, x minus 3 minus 2, so x minus 3. And then you get x minus 1, x minus 3, x minus 2. So your zeros in this case is 1, 2, and 3. These are the three zeros. When you do sum of all three, sum 1 plus 2 plus 3 is 6. And if you check, sum is nothing but negative b over a. Negative b is negative 6. And so negative 6, negative times negative 6 over 1, which is 6. Now we are going to do product, which is 1 times 2 times 3. It's 6, right? D is nothing but negative 6. Oh, my mistake. It is negative d over a. So negative 6 over negative 6 times negative times. So this is nothing but negative of negative 6 over 1, which is 6. So that's verified. The next one is the sum of products. 1 times 2 plus 2 times 3 plus 3 times 1, which is nothing but 2 plus 6 plus 3. So 11, which is which should be equal to C over VA. C is equal to 11 over 1 is equal to 11. So that is also equal. Okay, so that was the relationship between zeros and coefficient. What we learned today, we did types of polynomials, we did linear polynomial, quadratic polynomial, and cubic polynomial. And their zeros, linear has 1 0, cubic has 3 zeros, and quadratic has 2 zeros. We also did the graphical representation. Zeros are nothing but where the graph of that particular equation touches the x-axis. It could be for linear equation, it will touch 1 times. For quadratic, it can touch 2 times, 1 times, or 0 times. And for cubic equation, it can touch 3 times, 2 times, 1 times, or 0 times, right? The relationship between zeros and coefficients for quadratic and cubic equation. In quadratic equation, products of zeros are going to give you C over A, and the sum of zeros are going to give negative B over A. In cubic equations, product of zeros are going to give negative D over A. Sum of zeros are going to give negative B over A, and sum of products are going to give you C over A. That's your entire polynomial chapter. 10 practice questions for today. You have to find the zeros and identify the types of polynomials and verify the relationship between zeros and coefficient, and that completes the chapter polynomial. It comes for 5% weightage in your exam. Very easy to score. Don't miss out on the steps and the easy marks that you can get in these exams. Drop your answers in the comments and I'll see you in the next lesson. Until then, keep studying and good luck. If my video helped you in your preparation for the board exams, do like, share, subscribe, and comment to let me know. Share this video to all your friends and family who are preparing for their board exams, and tune up for the next chapter in my next video. Until then, keep studying. Good luck. Bye-bye.